Hey guys, we're ready for our next lesson in chapter 6. We're going to be talking about rotations. Hopefully whenever you hear the word rotation in your mind, you're already thinking that it's a turn. When I rotate, rotate your tires, or when you see something rotating, you know that it's turning. It's no different in mathematics. We're still talking about turning an object, only now we are doing it with some rules. So let's look at this. Pablo, who is this handsome little gray guy right here, is spinning this wheel. He's going to win the big prize. And it says that a spin can be clockwise or counterclockwise. Well, if I think about that, yes, I can rotate clockwise or I can rotate counterclockwise. And the first thing we want to define are what clockwise and counterclockwise is. Well, if you think of a clock, and I know that most of you only know digital clocks, but if you think of an analog clock, the one that is round with the numbers around it, to go clockwise, the hands are moving to the right. So a clockwise rotation is when it turns to the right in this direction. Okay? A counterclockwise then, counter means opposite of, so counterclockwise is the opposite of clockwise. So if clockwise turns to the right, counterclockwise turns to the left, or this way. So a clockwise goes to the right, a counterclockwise goes to the left. So now it says if the section labeled 8 on the left part, so it's right here, because this is the right, if I broke this down the middle, this side is the left, this side is the right. So it says the section labeled 8 on the left part of the wheel spins 90 degrees. So it's about right here. In order for it to spin 90 degrees, hopefully you know 90 degrees means that this is a 90-degree angle. I can draw that box in the corner. So if it spun 90 degrees clockwise, which means that it's going to the right, if it spun 90 degrees clockwise, where would it land? Well, it would land 90 degrees from there, is about at the top. Okay? Now it says if one section labeled 4, here's a section labeled 4, here's a section labeled 4, it says one of those sections makes 3 complete turns counterclockwise. So it's going this direction, 3 complete turns. And in a circle, how many degrees are in a circle? Well, there's 360. So if I do 360 3 times, there's 360, there's another 360, and finally a third 360. 360 times 3, or if I added that all together, I would have 360 once, 360 twice, 360 the third time, and my answer would be 1,080. So how many degrees has it traveled? It's traveled 1,080 degrees. And then it says, are there any points on the wheel that don't move? If I spun this wheel, is there anything on the wheel as it's spinning around that's not going to move? Well, the wheel has to be attached somewhere, and it's going to be attached right here in the center. So yes, there is a part that's not going to turn, or that's not going to rotate, and it's at the center. Okay? Then it says, does the center of the wheel change if the wheel is spun counterclockwise? It doesn't matter what direction I'm spinning the wheel, it's always going to be the same. The center is never going to change. So does the center move? No, it stays the same. Does the distance from the center move? So is this 4, let's say I spin it, does this 4 ever get closer to the center and further away? Well, the answer is no. It always stays the same distance. So the distance from the center always remains the same. This wheel isn't going to shrink just because I spun it and then get bigger because I spun it. It's always going to be the same distance. Okay? So let's look at some examples. This is talking about definitions, and this is a rotation. A rotation, again, is just when a figure is turned. We've already talked about that, around a fixed point like the center of the wheel. The center of dilation, or the center of rotation is that fixed point. So the center of rotation for this wheel is the part that doesn't move. So we decided what part doesn't move when I spin it? Well, the center doesn't move. So the center of rotation for this example is the center of the wheel. Okay? So let's look down here. Graph paper so that I have more room. But it says rectangle ABD. So I know that I'm dealing with a rectangle. So I'm going to draw my coordinate plane. And it says rectangle ABD. A is at -7, 4. Okay. So I'm going to draw at -7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So here's my A. Point B is at -7, 1. So -7, 1. Here's my B. Point C is at -2, 1. And point D is at -2, 4. So here's my original figure. And it says that I want to take this and I want to rotate it 90 degrees clockwise. So I'm going to go to the right. So I'm going to rotate it this way, 90 degrees. So let me do that again. Here's where I'm at right now. This is my orientation of my rectangle. I want to do 90 degrees clockwise. So I'm going to go to the right. And I want to do 90 degrees. So I want my pin to make a 90-degree angle with my pin. It would have to be straight up and down. Does everyone see that 90-degree angle? So I want my black cap is going to go from here, and then I want it to be pointing straight up and down. So when I do that, to make my black cap straight up and down, my A and B now are going to be up at the top, because if you look here, the black cap is touching my A and B. When I do 90 degrees, my black cap is now at the top. So now my A and B are at the top. So let's do that. Well, my C stays the same because that's my center of rotation. C to B is 1, 2, 3, 4, 5 spaces. So I'm going to go 1, 2, 3, 4, 5 spaces. Here is my new B. Okay, I've taken this, let me touch C to B is right here. The C is at the bottom of my cap. The B is at the point of my cap. If I go 90 degrees, the C is still at the bottom of the cap, and the B is now at the top of the cap. And then A is 1, 2, 3 from B. And D is 1, 2, 3, 4, 5 from A. So here is my new figure. And this is A prime because this is my new A. This is B prime because this is my new B. This is C and C prime because that didn't change because C was where I rotated from. And this is D prime because this is my new D. So here is my original image. When I rotated it 90 degrees, this is now my new image. Okay? Let's go on. Let's look at page 477. These are rotations about the origin. This is a 90 degree. Hopefully you can see, let me zoom in just a little bit. Hopefully you can see this 90 degree angle right here. It makes a 90 degree angle going through the origin. So that's a 90 degree rotation. A 180 degree rotation then is a straight line through the origin because 180 degrees represents a straight line. And 270 is a straight line plus 90 more. Okay, or it's 390s if you want to look at it that way. So now let's look down here. Oops, let me back out a little bit. We're going to go on to this last example. And it says quadrilateral MNPQ. So again, we're talking about 4 sides. So M is at 2, 5. So here is my M. N is at 6'4". So here's my N. P is at 6'1". And Q is at 2'1". So here's my quadrilateral. Okay, now if I connected all of those sides, I would have my quadrilateral. Quadrilateral just means four-sided. It doesn't mean that all the sides have to be the same length. It just means that it's four-sided. So here's my quadrilateral. And it says graph the new image. You want to do counterclockwise, so we're going to be going this way, counterclockwise, and we're going to go 270 degrees about the origin, which means the origin's not going to change. Okay? So I'm going to take this and I want to go 270 degrees. Well, if I look at this right here would be 90. A straight line would be 180. So, oops, let me click off of that real quick. So 270 is going to be down here. Okay, does everyone see that? I went 90 degrees, 180 degrees, which is a straight line, and 270 degrees, which is down here. So my new image then, my new Q is right here, because that's 270 degrees is right there. My new P is down from Q because I took this figure. Okay, let's look at this by pin cap. Q and M are together. Okay, Q and M, Q and M. It's hard to see. And then finally, Q and M. Okay, so Q and P, from Q to P it is 1, 2, 3, 4 spaces. So 1, 2, 3, 4 spaces. This is my new P. So P prime. From P to N, it's 1, 2, 3 spaces. So it's 1, 2, 3 spaces to my new N. And from N to M, well, I'm going to go Q to M because that one's an easier measurement because this one's slanted. From Q to M is 1, 2, 3, 4 spaces. So it's right here. This is my new M. And if I connect all those, there is my new image. Okay? Try some of these on your own. If you have questions, please bring those to us. Otherwise, we will see you tomorrow. Have a great night.